Hello, statisticians. Today's lesson is on conditional probability. Let's get started. When folks take the plunge and try to find their special someone online or on dating apps, sometimes it goes very well. Other times, people may find that a connection they've made online doesn't always translate to a connection in person, especially if someone's carefully crafted online profile doesn't quite stack up with reality. So that brings us to our key question for today. Can we use statistics and probability to find out how many people lie in their online dating profiles? With that question in mind, let's move on to our notes. We're going to cover 3 topics today, starting with Venn diagrams and intersections. Here's what's known as a Venn diagram, which in this case describes the probabilities behind 2 events, event A and event B. Here's how Venn diagrams work. So if we want to find the probability of A, or the probability of event A occurring, we would look at all the numbers contained in the entire event A circle, everything in this circle corresponding to event A. Then, if we want to find the probability of event B occurring, we'd look at all the numbers contained in the event B circle. Now, take a look at this notation. That symbol that kind of looks like an upside down U means and. So this means the probability of events A and B both occurring. And that's going to be where the circles in the Venn diagram overlap. Somewhere here in the purple. That's the only area in which both A and B are simultaneously occurring. In probability, the word and means both. So we're looking for the place where A and B are happening. The more formal terms for this are the intersection, or the place where A and B intersect, or the joint probability of A and B. Now, from an earlier lesson, we know that this notation means the probability of event A not occurring. We call this the complement of A. It's the probability of event A not happening. So that probability can be found in all the areas of the diagram except for the circle that describes A. Let's use these ideas as we return to our main context of the day, the truthfulness of online dating profiles. We'll be analyzing data from the dating site and app OkCupid. Specifically, our data set is composed of public OkCupid profiles created by 36-year-old heterosexual men living in the San Francisco area in 2012. And if you're wondering why we picked 36-year-olds, well, that's the average age where singles start feeling more social pressure to find someone, and therefore the temptation to lie in their online dating profiles is potentially higher. Now, there's a couple of key figures to know here for context. First, according to the US Census Bureau, the median yearly earnings among individual men living in San Francisco in 2012 was $59,379. And according to the CDC, the median height among males in the US is 69.2 inches, or just over 5'9". Recall that the median is the 50th percentile, so that means that 50% of men should be at or below this benchmark for income and height, while the other approximately 50% should be above them. So, to help us categorize the dating profiles, we break them down like this. If someone's profile describes themselves as above medium height, we are going to classify them as tall. And if someone's profile reports them as an income above the median, we're going to classify them as a high earner. So in the data, we gathered 192 OkCupid profiles, and we found that 123 of the men reported that they were tall or above median height. 101 reported that they were tall and high earning, meaning that they were reporting above median height and reported making more than the median income. And finally, 21 reported that they were neither tall nor high earning. So this brings up the question, if they were to swipe from the profile among these random people, Would you get matched with one of the profiles? And would that person be a high earner? Now, when approaching a probability problem like this, many students go straight to formulas. And while formulas can be useful, our experience is that formulas often make probability problems feel like a maze. It's hard to know where to start and what to plug in. And so, students get lost. Now, don't get me wrong, in this unit, we're going to cover these formulas and show you how they work. You should know how to use them if you like them. But here's our advice. Try solving using your reasoning skills and the keys to probability before turning to any formulas. So, what are the keys to probability? I'm so glad you asked. Here they are. If you keep these keys in mind, many probability problems become a lot more straightforward. Over this course, you are going to cover all of these. For today, we're going to walk through a couple of them, starting with the first one, which is a good first step for most probability problems that you will encounter. Draw it first. So here's more information about the OkCupid problem that was given to us. To help us get organized, we are going to define the info in terms of two events. We're going to let T equal the event of selecting someone who is tall, and H equal the event of selecting a high earner. So we can take these events and give them circles in a Venn diagram, which will help us organize all the information. First, we were told that 101 of the profiles reported being tall and high earning. Since these profiles have both characteristics, they fall into the intersection. And then there are 123 men who are tall. So that means that the total number in the tall circle should add up to 123. 101 of the tall profiles are already accounted for in the intersection. So we need to figure out the remaining X profiles that are also tall but are not high earning. So some X profiles plus the 101 should get us 123 tall people. That number is 22. 22 plus 101 equals 123. So 22 of the profiles report being tall but not high earning. Now, the last part of the description shares that 21 of the men are neither tall nor high earning. They don't go in either circle, so we account for them by putting their count outside of the circles. Finally, we need to decide how many men are high earning but not tall. We're going to use an unknown Y. Since the total of the sample was 192, we can solve for Y by adding all the parts together and seeing how many profiles must fit into this remaining category to get the total of 192. So we do the addition and we see that we've already described 144 profiles in our diagram. So there must be 48 profiles remaining to get us to the 192 total. This means that there are 48 men who are high earning but not tall. So our diagram gives us the information we need to solve the original problem. What is the probability of selecting a high earner at random? In other words, we're looking for the probability of event H, which is everyone in the circle who is high earning, regardless of whether or not they are tall. So we add up everyone in that circle, 101 plus 48, and then we see that that's 149 high earners total out of the total number of men, which is 192, and that gives us a probability of 0.776 or 77.6%. In other words, we have more than a 75% chance of finding a high earner when we randomly swipe on the OkCupid dating app. So clearly, the men on OkCupid are doing pretty well for themselves financially. Another calculation we could do to find is this. What is the probability of selecting someone who is both tall and a high earner? So this is the 101 people who are both tall and high earning out of the 192 people total. That gives us a probability of 52.6%. Now let's take a look at this. This is the probability of T complement, or not tall, and high earning. So we can see that the not tall and high earners are 48 profiles out of the 192 people total, or 25%. Now, we can also turn back to this. The probability of selecting a person who is tall, regardless of whether or not they are a high earner. That describes everyone in the tall circle, or 22 plus 101, which gives us 123 people out of the 192 total, which is 64.1%, a whopping 64.1%, which again is very impressive. Clearly, there's a lot of tall people trying to find love on this dating app. And finally, one less probability to showcase is this one. What is the probability of T complement, selecting someone who is not tall? Here's what it looks like in our diagram, in which we are now capturing everyone except for those people who are tall. So that is 21 and 48 people outside of the tall circle, which brings us to 69 out of 192, or 35.9%. And note that this should make sense because it is the complement, or 1 minus the probability of someone being tall. And recall earlier that the probability of someone being tall was 64.1%, so that checks out. Now, to sum this up, remember that we define tall as being above the median height and being a high earner as being above the median income. And we said median means 50%. But among the male OkCupid users in San Francisco, a whopping 64% were tall and 77.6% were high earners. With numbers like these, it appears that the probability of finding a taller man and a wealthier man is much higher on the internet than in the physical world. So this suggests two possibilities. Either 36-year-olds dating online are truly taller and wealthier than the general population, or some users are just lying on their profiles. We'll never know for sure, but if I had to make a bet, I'd say it's probably the second option. It's just hard to believe that 36-year-olds in the dating world online are truly that much taller and wealthier than in the general population. So let's continue onwards by looking at our next topic, mutually exclusive events. Mutually exclusive events are events that cannot occur at the same time. These are sometimes called disjoint events. A Venn diagram for mutually exclusive events would look like this. For example, you can turn left and you can turn right, but you can't do both at the same time. As you can see, there is no intersection or overlap, as turning both ways is not possible to happen at the same time. So the probability of the intersection is 0. The last probability concept that we'll look at for today is conditional probability. A condition is a given in a problem, something that you already know has occurred. We represent conditions or givens with this vertical line notation. So this statement means the probability of A given B, or the probability that A will occur given that B has already occurred. Going back to our keys to probability, conditional probability is where dividing by the givens comes into play. Recall that we found the probability of selecting someone who is tall was 64.1%. So now let's take a look at this probability. This is the probability of selecting a tall person given that they are a high earner. And since we're given that they are a high earner, this eliminates the probability of selecting anyone who is not a high earner. So we can ignore anyone outside of the high earner circle. So the new sample space of possible outcomes is the given, the number of high earners. So that's why this is the key of dividing by the givens. So the new denominator is 149, the high earners. And among those 149 earners, it's looking like the probability of felling a tall person is the 101. That becomes your new numerator. So the probability of selecting a tall person, given that they are a high earner, is 67.8%. Now, you could use a formula to solve this as well, and let's see how that works. Using this formula, the probability of t given h is equal to the probability of t and h divided by the probability of h. So the total of h is the denominator, and the total of the intersection of t and h is the numerator. And so we plug in these values and calculate this probability, which is exactly the same as our results when we used the divide by the given key to probability. So ultimately, if you use the formula or if you use the keys to probability, you'll end up in the same spot. Now, here's one last conditional probability that I'd like for us to calculate. Let's find this, the probability of selecting a tall person, given that they are not a high earner. This time we're looking at people who are not high earners. That's our given. So for these people, anyone who is not a high earner. So that's our new sample space and our new possible outcomes, and that becomes our denominator. We're dividing by the given. That gives us a total of 43 profiles. And out of those 43 people, we want to know how many of them are tall. So out of those 43 people, 22 of them are inside of the tall circle. That's our new numerator. Dividing these numbers, that gives us a probability of 51.2%. So if you know that someone is not a high earner, there is a 51.2% that they will be tall. So that brings us to our discussion for today. On many dating apps, you can filter results. Unfortunately, there's no filter for honesty. But what if there was? And that is our discussion question. How could OkCupid members set their filters to obtain more honest matches? And here's a hint to get you started. Compare these two probabilities that we calculated earlier. So take a moment to jot down your initial thoughts to this question, and we'll discuss it further in class. That's it for today's statisticians. We'll see you next time.